Hi learners, welcome back to my channel Onlineshala. So today we are going to study about atomic structure. So before we get into the video, I would request you all to please subscribe to my channel first so that you will be notified every time I put up a video next. So now let's start. So now what is atom? Let us see the basic definition of it. What is it? So the smallest unit of any element is called an atom. So this whole world is actually made up of atoms, and these atoms of different elements combine with one another to form new substances called compounds. So these compounds have no electric charges on them and are neutral in character. So these atoms are so small that we cannot see them through our naked eye. They are just basic building blocks of the matter. Whether it is solid, liquid, or gas, wherever you see, you'll find atoms in it, which constitute them. So I'll give you an example of compound first. So let us take a sodium atom and a chlorine atom. So these two are two different atoms, and when they add up, they form NaCl, which is nothing but your common salt or table salt. This is called sodium chloride. This is the chemical formula. So like this, there are many examples of atoms. In the process of the video, I'll be telling you some examples like these. So let us say John Dalton's atomic theory of matter. So John Dalton in 1803, he states that he's assuming that atoms are ultimate indivisible particles of matter. So what is indivisible particle means is that they uh, they cannot be divided into two like this. See, they cannot be splitted into two other substances. So they can form with other atoms, but they cannot be divided. So he states that they are indivisible particles called atoms. Atoms of same element are alike in all respects. So you see this atom, both are alike. So in all respects, whether it is sodium or chlorine, both are alike. Atoms of different elements are different in all respects. Atoms combine in small whole numbers to form compound atoms or molecules. Or see this one atom combines with the other two and the other two becomes four like that. So they form a compound like this NaCl. Atom is the smallest unit of matter which takes part in a chemical reaction. Yeah, atom is the smallest unit of matter. We have already discussed that. And yes, they take part in a chemical reaction to form a compound. So those are the 5 points of what John Dalton stated. First is they are indivisible particles. Next is they are alike in all respects. Atoms of different elements are different in all respects. Then atoms combine in small whole numbers to form compound atoms. Then the last one is the atom is the smallest unit of matter which takes part in a chemical reaction. Now every scientist have a different approach of atom. So John Dalton stated in those theories and he observed that in an atom. Now let us see what J.J. Thomson's model of an atom states. So J.J. Thomson discovered a particle which was electrically charged and has mass um, had mass equal to 1 by 1837 times the mass of hydrogen. So the charge on this particle was negative, and he named this negative particle as electrons. So as atom is electrically neutral, already there is a negative charge called electron. So now there is a presence of positively charged particles called protons. It was found that its mass is equal to mass of one atom of hydrogen. So no two elements have same number of protons. For example, number of protons on helium and lithium, if you see, they are 2, 3. So it was assumed that the number of electrons in an atom is equal to the number of protons as the atom is electrically neutral. So J.J. Thomson proposed an atomic model which is called apple pie pudding model of an atom, which is a very famous theory. So wherein uh, you can see there is a sphere here and they are negatively charged and positively charged particles here. So he assumed an apple pie. I have put a watermelon over here. So this the whole red part in this watermelon he assumed to be as protons, the positively charged particles, and the black seeds which are there here, he assumed it to be the electrons. Further, it was assumed that total positive charge is equal to total negative charge. Therefore, the atom remains electrically neutral and it satisfies the condition of John Dalton's theory, which we have seen before. He took this apple pie pudding theory because the electrons, the negatively charged particles, they are actually very less in number and they revolve around the nucleus. And the positive charged particles are very large in number and constitute almost a whole of the atom. That's why they have given the apple pie pudding example, and you can also take the watermelon example as well. But there is a drawback in this also because J.J. Thomson was unable to explain how positively charged particles are shielded from negatively charged particles without getting neutralized, because there are positive charged particles here and also negatively charged particles. So how they not get neutralized is the questions that many fellow physicists asked him, so which he couldn't clear. So that is the drawback of this model. So as we have seen what is atom, compound, and John Dalton's theory and J.J. Thomson's famous atomic model of apple pie pudding. So let us see what is Rutherford's experiment, which is the discovery of nucleus. So Rutherford performed an experiment by taking a source here which has very small and positively charged particles called alpha particles, and then he took a gold foil placed in between, and then all this is protected by a detector. So first he observed some things, and that is that the most of the alpha particles pass through the gold foil without any deviation from their path, like from the source right they fall onto the gold foil and then straight onto the detector, so there's no deviation. But he's seen that some of the particles have deflected with a smaller angle, like this one, and some and very small number of them are completely rebounced back to their original path. So, based on these two observations, Rutherford has put forward the new model of an atom. So, what he observed is that the mass of an atom is concentrated in a very small space within the atom called the nucleus, and it is positively charged. Nucleus is positively charged. This explains the deviation and rebounding of some positively charged alpha particles. The atom is almost empty from within, such that the size of nucleus is almost negligible as compared to the overall size of an atom. So suppose this is an atom here and this is the nucleus. So compared to the whole of the atom, the nucleus mass of this is the size of this is negligible compared to the overall size of the atom. That's what he said. Then the electrons revolve around the nucleus. So the electrons, they move around this nucleus in a spherical path. They move around the nucleus in a spherical path, and he gave an example of this for compared to the solar system. So now we assume here the sun as the nucleus, the center, and the Earth, Mercury, all the planets, he assumed them to be as the electrons as they move around the nucleus in an elliptical path. The same thing in an atom also. Around the nucleus, the electrons revolve in a spherical path. So they move at a very high speed and hence they do not fall into the nucleus. In an atom, the number of protons is equal to the number of neutrons. As the atom that we already know that it is electrically neutral. So to balance that, always the number of electrons is equal to the number of protons. So he compared this theory to the solar system, which is the perfect example to explain the motion of the electrons around the nucleus. Electrons, which are the negatively charged particles, and neutrons, the positively charged particles. And the electrons do not fall into the nucleus because they are electrically neutral. An atom is electrically neutral. So there's one drawback for this, that is, he failed to explain the position of electrons with respect to each other and the positively charged nucleus. So till now we have seen that the mass of an atom is concentrated within its protons and the electrons have practically negligible mass. So the atomic mass of an element should be equal to the mass of its protons. So atomic number of an element is equal to the number of protons present in the nucleus of its atom. Now for example, it is hydrogen. So for hydrogen, it is 1. The atomic number of hydrogen is 1 because there is only one atom present in the outermost shell. Experimentally, we have found out that the mass of the protons is compared far less than the atomic mass. So this difference in the mass was explained by saying that there are no electric charge and these unknown particles were named as neutrons. As the mass of the protons was very small as compared to the atomic mass, so they couldn't find the difference. So that difference only they named as neutrons, which had no electric charge. So this A here represents the mass number, which is the number of protons and neutrons in an atom, and X here represents the atomic symbol. Like you can take here the sodium or hydrogen. So this is the atomic symbol. And Z, this represents atomic number, which is number of protons in an atom. For hydrogen, like it is 1, or for sodium it is 23. So the mass number here, the top part is called the mass number and the below part is known as the atomic number. Mass number is represented as A, atomic number is represented by letter Z. So here we have an example of a carbon atom whose mass number is 12 and the atomic number is Z, I mean 6. It is represented by Z. And this is mass number, which is represented as A. So as we know that the atomic number, what is the atomic number definition? It is equal to the number of protons. So atomic number is 6. Means how many protons do we have? 6 protons. And what is the mass number here? 12 is the mass number. So how to calculate neutrons, number of neutrons? So it is the difference between the mass number and the atomic number. So those difference only we called, those unknown particles only we call neutrons, right? So 12 minus 6. So number of neutrons, capital N. So we represent number of neutrons as capital N, and uh, the mass number A, atomic number Z. So 12 minus 6 gives you 6 neutrons. Yeah, that is the example, that is a small example of this, how to calculate mass number, atomic number, and number of neutrons, how to identify. So anything, if they ask the number of neutrons value, you just need to subtract A minus Z, that is mass number minus atomic number. Simple ways to remember that the top number minus this lower number, you get the number of neutrons. And number of electrons is also same. This is 6. So this table here I have just put up so that you can see the charge of the proton is always positive, that is +1. Mass is 1 and nucleation is nucleus. Neutron here which is no electric charge, so it is 0. Mass is 1 and the location is nucleus. So proton and neutron are here combined, and this other big circle here, there are electrons present here. And electrons, we know that is negatively charged particles, so its electric charge is, so its electric charge is -1 and mass is 0, and its location is present in orbitals. So this is just a little bit more information about protons, neutrons and electrons. So now let us go on to see the constitution of nucleus in an atom. So according to Rutherford, an atom is almost an empty space in center, which has tiny protons and neutrons here, and all this here he thought is an empty space. He called it the nucleus of an atom. In the nucleus of an atom, the protons are held so closely, so tightly, that the forces at the short distance start attracting the protons. So no matter the positive charge try to repel on them. So these forces at short distance are called nuclear forces. As a matter of fact, there is an equilibrium between the attraction due to the nuclear forces and repulsion due to positive charge. So an equilibrium is actually generated between the attraction due to nuclear forces and repulsion due to positive charges, as at a short distance only they start attracting the protons. So that's why they try to repel. So that's repulsion due to positive charges. So there are some conclusions that are being drawn from this nucleus of an atom, that is, the entire mass of an atom is provided by the mass of the protons and neutrons within its nucleus. So this entire mass of an atom, actually it is the mass, the majorly constitutes the mass of the protons and the mass of its neutrons within the nucleus. And these electrons here, they have negligible mass, like you can neglect them, they are not such greatly involved in the mass of an atom compared to protons and neutrons. So that's the first thing. So the second thing is that the entire positive charge on the nucleus is due to the number of charges on individual protons. So this entire positive charge inside the nucleus of an atom, this is due to the number of protons, individual protons, majorly because of them. That is, the constitute the positive charge. Protons are positive. So the third thing is that the nucleus is stable in nature because the attraction due to nuclear forces counterbalance the repulsion due to positive charges. So there is a stable between the attraction and repulsion. So like that, the atom helps to be electrically uh, neutral. So the fourth as the conclusion is that the protons, neutrons, they are collectively called as the nucleons. Okay, they are called as the nucleons. Now, for example, if there are 4 protons and 4 neutrons in the nucleus of an atom, then the number of nucleons is what? 4 plus 4, 8. So total there will be 8 protons and neutrons if we take that example. So this the electrons are so the electrons charge is mass is negligible, we know that, and the protons and neutrons only constitute majorly to the mass of the whole atom, and the protons are majorly they have the positive charge on individual protons, and so the protons and neutrons are what collectively called as the nucleons. So the example we have seen that if there are if there are 6 protons and 6 neutrons also, if you add them, they are so 12. So there we usually say there are 12 nucleons in an atom. So when they mean nucleons, you should just understand that it is the addition of protons and neutrons, which is called nucleons. Modern atomic model. So what is it? Let's see. So we know that an atom consists of three main subatomic particles, which is the proton, neutron, and electron. So first, let's see what is a neutron, like full detail in it. We already know that some basic things about it, but let's go in detail. So neutron has no electric charge on it. Okay, see the charge is zero. It is all its mass is almost equal to mass of one atom of hydrogen. It is denoted by the symbol N, but on the top it has 1 and over here 0. So this is how it's represented. So I already told what is the top part. It is called here. It is called the mass number. 1 is its mass number. See, 1 is the mass number here, and 0 is the atomic number because it does not have any atomic number. So it is 0. So yeah, that is about proton. Its symbol is N, mass 1, charge is 0. So what is proton? So proton is a unit positive charge. It is almost equal to mass of one hydrogen atom. So it is also denoted by like this P, and on the mass number is 1, the atomic number is 1. I have already shown you the representation of mass number and atomic number. Mass number comes on the top, atomic number comes on the bottom. So proton over neutron over, so what is there? Electron. So electron has a unit negative charge on it, so it has a negative charge here. A proton here has a positive charge, electron negative, and neutron does not have any charge, it is 0. So electron's mass, actually it is 1 by 1837 times the mass of one atom of hydrogen. I have already mentioned that before also, that it is 1 by 1837 times the mass of one atom of hydrogen. Okay, it is very important, so please remember it. So, and hence it is negligible. The mass of it is negligible. So it is denoted by the symbol E, and here it is minus, and in the superscript, that's the top part, it is 0, and here it is minus 1, and the charge is minus 1, and in the mass of it is 1 by 1837 times the mass of hydrogen. So protons and neutrons, they form the central core of an atom, which is called the nucleus. We already know that the protons and neutrons. What are they consecutively called? I've already told you before that proton plus neutrons. What are they called? They are called nucleons. So the protons and neutrons are held firmly in the nucleus by strong nuclear forces. So the electrons, see this diagram over here. So they are this yellow balls here. These are the positive charge. This is the protons. Okay, and this orange colored balls here, they represent are the neutrons. So okay, this doesn't look like P, but okay. Okay, this positive thing is proton, and the negative are the, so the positive are the protons, and the other particles, which are the unknown particles, they named it as neutrons. So they constitute the nucleus of an atom, and the surrounding here in the orbits, you can see these negatively charged particles. They are called the electrons, which, yeah, you know before only we have discussed it. E minus, because they are negative charge, and this protons is plus. So while representing or while writing, you have to represent it as P plus and electron minus, and neutron, no need to put any charge, we know it is 0, so it doesn't matter. So the electrons in this shells close to nucleus are held by strongly by electrical pull of nucleus. Okay, so these electrons are called bound electrons. So this shell over here, this first shell, there are two electrons in here, so the attraction is more. So these electrons are called the bound electrons, and they experience a very small nuclear force because the distance between them and nucleus is greater. Actually, in the representation, the space is shown small, but the atom is actually a whole empty space, and it only small part of it constitutes the protons and neutrons, and it is almost empty space. An atom is empty within. So, however, these electrons in the outermost shell, you can see outermost shell in the last orbit, like in the outermost orbit, the last one, they are called the valence electrons. Valence electrons are the electrons which are in the last orbit of an atom. So as the atom of a normal element is electrically neutral, therefore, it is concluded that the number of protons in the nucleus is equal to the number of electrons revolving around the nucleus, because an atom is electrically neutral. So obviously, it balances the positivity and negativity. That's why the atom is electrically neutral. So once more I'll tell you this representation. It is the top part here. This represents the mass. Okay, this represents the mass, and the down part here represents the charge. So 1 1, and here the top part mass, down part charge. So it is 1 0, and the mass, this 1 by 183.7 types of hydrogen, which is, I told you, it's almost negligible. So we take it as 0. So this mass is 0, and the down part here it is minus. So we represent it as 0 and -1. So I hope that you have understood what is this bound electrons and the valence electrons. They are the electrons in the outermost string or outermost orbit, you call it, and these are the bound electrons that which held strongly by electrical pull of the nucleus. So here we come to the end of the, I can say, part 1 of the atomic structure. So let us see the summary of what we have studied first. So first we have seen what is an atom, it's the smallest unit of an element, and different elements combine together to form new substances called compounds. Then the negatively charged particle is called electron, positively charged is called a proton. And electrons, they revolve around the nucleus with high speed, and they do not fall into it. So we have seen the John Dalton theory, then we have seen the J.J. Thomson theory, how he told about the famous apple pie pudding model of an atom, where you can see the most part of it is covered with protons. Like you can see the example of a watermelon, and those seeds are represented as the electrons. That is the example which he gave. Then we have seen that in an atom, the number of protons is always equal to the number of electrons, and the atomic mass of an element should be equal to the mass of its protons. But we have seen that there is that the mass of protons is far less than the atomic mass. So that difference they have given a name as neutrons, which has no electric charge, and it is electrically neutral, and it does not have any charge. And then we have seen that all the space containing protons and neutrons are called nucleus of atom. Okay, the protons and the neutrons, they are called the nucleus of atom, and surrounding them are the electrons, which are the negatively charged particles, and they revolve around them in an spherical path, just like the solar system. We have seen that example, just like how the around the sun the planets revolves, in that same way around the nucleus the electrons revolve. So protons and neutrons are collectively called as nucleons. Like we have seen some example, like if there are 6 protons and 6 neutrons, so what is the number of nucleons? They are 12. So you just add them up. That is the thing. And then we have seen also the representation, like how to know what is the mass number, atomic number. Mass number is represented by A, atomic number Z, and how you calculate the number of neutrons, which is the difference between mass number and atomic number, A minus Z. gives you capital N, which is the number of neutrons. So then the we have seen that the electrons in the outermost shell are called valence electrons. So yes, to sum up all this, we have majorly discussed. These are the major points we need to take away from this lesson. So thank you so much for patiently listening to all of this. And the next part of this atomic structure, I'll be soon uploading it. So I would please request you all to subscribe to the channel so that the new video you can be notified about it, and then you don't miss it and watch it. So thank you so much, and I'll see you guys in the next video.